Welcome back, everybody. Mr. Anderson here again for another edition of Algebra 2. Today, we are going to talk about the quadratic formula and the discriminant. No, that's not a movie. Sounds like that could be a movie title, the quadratic formula and the discriminant, or maybe a buddy cop show. Okay, but it's none of those things. This is just some more stuff with what we're doing with the quadratic equations. And so let's take a look at these. Our objective today, first of all, is to be able to solve quadratic equations using the quadratic formula. If you remember, some of the things that we've done before is we could take a quadratic equation and factor it and then get the solutions or solve it by factoring. Okay, that's one way we solved things before. Another way we actually did it was we had graphed before to find the solutions or the roots or the zeros. You might remember some of those. So this is another way to do that with the quadratic formula. The good thing about the quadratic formula is it will always work. If you're factoring, you may not always be able to factor to find the solution. Graphing, you may not easily be able to use graphing to find an exact solution. You can get maybe an approximation at times, but graphing's got some limitations too. So this will always work. And the other thing is then we want to use the discriminant to determine the number and type of roots in a quadratic equation, and the discriminant is part of the quadratic formula. We'll talk about that in a few minutes. Okay? All right, first of all, the quadratic formula. What is it? Well, you might have heard of this before. You might not have. But if you look here at the chart, this is the quadratic formula right there. Somebody remember when we had our quadratic equation in standard form like this, ax squared plus bx plus c equals 0? Well, somebody figured out, well, what do I know if this number is a, b, and c in general? When I solve this, where do all those A's, B's, and C's go? And this is where they end up. It's kind of a long, complicated process, so I'm not going to go through it. But if you have this memorized, then you can just take these numbers from the original equation and plug them into the formula and work that out. Okay? And we'll go through a few of those examples. Now, okay, at the risk here, taking a little risk here, maybe. There is a song that goes along with this that you may have heard of before. The tune is Pop Goes the Weasel, if you remember Pop Goes the Weasel. And a way to kind of help you remember this formula, and it may or may not. In the past, I've had some people say, oh, well, it doesn't really work because it doesn't rhyme or whatever, but, you know, maybe it'll help you. Might help you to remember this. So here's how it goes, okay? X is equal to the opposite of B plus or minus the square root b squared minus 4ac all over 2a. Okay, so that's the song there. A lot of people like the all over 2a part for some reason. But if you can remember that, you know, x is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. That might help you remember the formula there. Okay, so let's look at a few examples and see how this works. Our first example, and this is going to be when we're going to end up getting two rational roots. And I've put the graph in here. We don't necessarily need to graph this, but I'm just going to kind of show you how this compares here with the graphing. All right, so first of all, we've got our equation here. Remember, in order to get the A, the B, and the C, it has to be in the correct form. So I have to take this 16 and subtract 16 so that I have x squared plus 6x minus 16 equals 0. It has to be in that order. X squared comes first, then the x, then the number. Okay? So now, remember again, let me see, I don't know where I should kind of put this up here. Remember our formula again. I'll write it up here. I got some room here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's the formula there. So let's start plugging stuff in. What's b? b is 6. So we're going to say x is equal to the opposite of that, or if it's plus 6, it's going to be a negative 6. If this was a negative already, it would turn to plus 6. So you change the sign. Plus or minus the square root, b squared. That means we're going to do 6 squared, which is 36, if you want to save yourself a little work, minus 4 times a. What's a? A is 1, and c is negative 16. And this is all going to be over 2 times 1. A is 1. And again, as you do this a little bit more, you'll be able to kind of do some shortcuts along the way as far as filling in, like I did the 6 times 6 is 36. Here you might eventually just go, oh, that's 2 times 1, or just 2. You don't have to write the 2 times 1 in that step there. All right, so let's start simplifying this then. X is equal to negative 6 plus or minus the square root. Well, let's work all this stuff out here. What do we got? Basically, treat this as a negative 4 times 1. So that's still a negative 4 times negative 16. So let's go negative 4 times negative 16. Oops, I think I typed that wrong. Equals 64. So this would be 36 minus 64 all over 2. What's 36 minus 64? Negative 28. Okay, so let's simplify this down a little bit more. Oh, you know what? I missed something here really quickly. See this, when we did negative times a negative, that makes this what? Plus 64. Sorry about that. And so this would be negative 6 plus or minus. What's 36 plus 64? That's 100 all over 2. What's the square root of 100? 10. So this is going to equal negative 6 plus or minus 10 all over 2. Well, what does that mean? Plus or minus just means you've got, this could be negative 6 plus 10, or it could be negative 6 minus 10. And you have to work both of those answers out. In this case, since the square root of 100 worked out perfectly here, let's just find out what these actual numbers are. So first of all, what if we had negative 6 plus 10 over 2? What would that equal? Well, 10 minus 6 is 4. 4 divided by 2 is 2. There's one of our solutions. What if this was negative 6 minus 10 over 2? That would be a negative 16 divided by 2, which would be a negative 8. That's our other solution. So you notice we have a solution of 2 and negative 8. Now, if you noticed, if you were paying close attention here, remember when we got it into this form right here, the x squared plus 6x minus 16, you might have been able to factor this. And if you would have done this, you say what times what is negative 16 but adds up to be 6. You go 8 times a negative 2 is negative 16, but 8 plus a negative 2 is 6. You could have factored this, and then you would have ended up getting the same two solutions here, 2 and negative 8. And just just so you can kind of see here how this relates to the graphing, remember when we graph it, the solutions, if you remember, are where it crosses the x-axis here. And so we've got one that crosses at 2, and one that's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's slightly off here, but that's where the two are going to cross. And if I can get this here, x squared plus 6x minus 16. Just going to see if I can get anything else that's good there. You got negative 8, 0, and well, it looks like most of these other points are going to be kind of off our chart here. So basically here, just to kind of give you a general idea what this graph would look like, it might be something like this. Okay. So it's going to look something like that. It's going to go kind of way down off the chart here. But basically, it's going to be that U shape, and it's going to go through 2 and -8. That'll look something like that. But our solutions are 2 and -8. Okay? Next one. We got x squared plus 8x plus 16. Well, let's go through the same steps there. X is equal to the opposite of b, -8, plus or minus the square root. B squared, that's 64, minus 4 times a times c, all over, ooh, that's a little rough there, 2 times 1, or 2. Okay, so we just plug the numbers in just like we did before. Let's this time we have what? Let's see, x equals -8 plus or minus. This is going to be what? 64 minus, and this is going to be like a negative, because it's a -4 times 16. So minus 64 all over 2. What happens here? 64 minus 64 is 0. So this is going to be -8 plus or minus the square root of 0 all over 2. Well, what's the square root of 0? What times what equals 0? 0 times 0. So really what this means is I have -8 plus 0 divided by 2 and -8 minus 0 divided by 2, which basically this square root of 0 part here just kind of becomes meaningless. So really all I have is just -8 over 2, which equals -4. I just have one solution, or one root, as you notice I had in the title up here. Just one root. That means where the equation, where the graph crosses the x-axis here, is going to be at -1, 2, 3, 4. It's going to be one spot right there. Whoops. Just one spot right there. And if you went to graph that, that would look like this. X squared plus 8x plus 16. That we've got that point of -4, 0, and then it's going to be -5, 1. It's going to be a point here and here, and then at 4, so it'll look something like this. But you notice, where does it cross the x-axis? Just right at that one spot there. That's why we only get one solution, if you remember that from before. Okay? Irrational roots. Okay, so now we've got quadratic formula that we can use here, but we're going to get irrational roots. And I don't know if you remember this, way back at the beginning of the year we talked about irrational numbers. Basically, irrational numbers are square roots of non-perfect squares. Okay, so that means we're going to get a square root of something that's not a perfect square. And remember, at the beginning we got square root of 100, and it worked out to be 10. That was a perfect square. Or we got 0 in the last example. That basically became 0. Now we're going to get something that won't work out. So here's what we've got. X is equal to the opposite of b. So it's -6 here. So that means the opposite of that is going to be +6, +6. Plus or minus the square root of b squared. So that's -6 squared, which is 36, minus 4 times a, 1 times c, 2. Again, I'm getting those numbers from these right here. All over 2 times 1, which is just 2. So what do I really have here? 6 plus or minus the square root of 36 minus 8, it looks like, all over 2, which is, what's 36 minus 8? 36 minus 8, 28. So this is going to be square root of 28 over 2. Notice, that's not a perfect square. So this is where we're going to end up with irrational roots. But we can simplify this. If you remember, I don't know, well, a few sections ago, we did some simplifying of square roots. And remember, we can break this up into two things that multiply together, where one of those is a perfect square. And in this case, I'll just kind of going to draw a squiggly line here so you know this is different. Square root of 28 can be broken down into square root of 4 times the square root of 7. Square root of 4 is a perfect square, so this would be 2 square root of 7. So we can break the square root of 28 down into 2 square root of 7. So this is really going to be 6 plus or minus 2 square root of 7. That's a 7. All over 2. And then since it's all being divided by 2 here, remember whenever we've got something split up with a plus or a minus here, you can take this part over here, the 6, and divide it by 2, and you can also take this and divide by 2. So 6 divided by 2 is 3, and then this 2 divided by 2, this is this kind of works the same way. I guess you could say if this was 2 times x over 2, the 2's would cancel here. So this would just be 3 plus or minus the square root of 7 would be our answer there. Now notice, this is how you could give this answer. This is the exact location. 3 plus square root of 7 is one exact location, and 3 minus the square root of 7. Those are two roots, and they're irrational because they've got an imperfect square root there. However, you could also, if you wanted to approximate the roots, you could just type that in your computer or your calculator and just do, 3, type in 3 plus the square root of 7 equals, and it would tell you this would be approximately, so 3 plus the square root of 7 would be approximately 5.65, and 3 minus the square root of 7 then would be approximately 0.35. So this is the exact number here, the exact roots, 3 plus the square root of 7 and 3 minus. But if you were going to go graph this, and then of course what I've got here is there's a graph here. That's what the graph would look like, and if you notice right here, that's going to be your 0.35, and the 5.65 is going to be this part out here. So remember before when we did this and we didn't have perfect roots, we'd say, oh, it's between 0 and 1, or it's between 5 and 6. Well, now we've got a way to find these more exactly. Okay? So that's if you get two irrational roots. And then complex roots, and again, a complex number is made up of a real number and an imaginary number. That's why it's complex. And so what's going to happen on this, remember, imaginary number, you have a square root of a negative number. So what's going to happen on this one, we're going to get a negative number inside the square root. And that's what's going to cause us to have an imaginary number, or complex. So again, we have to get this in the right order, so I'm going to go minus 4x. So x squared minus 4x plus 13 equals 0. X is equal to the opposite of b. Make sure you have these in the right order. So 4 plus or minus the square root, b squared. That's going to be 16 minus 4 times a, 1, and c, 13. All over 2a. So all over 2, because a is 1. All right. What do we got here? Negative 4 times 13. That's going to be a negative 52. So I have 4 plus or minus 16 minus 52. 16 minus 52 is a negative 36. So I've got x equals 4 plus or minus the square root of negative 36 all over 2. Now 36 is a perfect square, but the negative causes us to have an I here. So basically what we end up with is what? 4 plus or minus, remember square root of negative 36, the square root of negative 1 is I, and the square root of 36 is 6, so this would be 6i over 2. And again, to simplify this a little bit, since both of these numbers up top here will divide by 2, we'll simplify that. So 4 divided by 2 is 2. 6 divided by 2 is 3. So this will be 2 plus or minus 3i would be your solutions. Again, notice since there's a plus or minus, there are two roots there. You know, one of those is 2 plus 3i, and one of those is 2 minus 3i. So you do have two roots, but they are considered complex because they've got the I in here. You know, you've got the real part of the number and the imaginary part of the number, but you've got two of those. And if you were to graph that, it would look something like this. And if you notice, the graph here does not cross the x-axis. That's why these are imaginary solutions or imaginary roots here. Okay, so when you go to graph something like this, and before when we saw this we said, oh, no solution, you know, or something like that. Now there is a solution, it's just that the numbers are imaginary numbers. So, so it would look something like that, where this graph will not cross the x-axis when you have complex roots, or in other words, imaginary numbers in there. Okay? Now the discriminant. Okay? The second thing we got to talk about is the discriminant. Remember I said part of the quadratic formula is made up of the discriminant. What part is it? It's b squared minus 4ac. It's the part that's underneath the square root. That's the key part. Okay? Because depending on what that number is, that will tell us what the roots will look like. I did it one example of all the 4 different kinds. You know, one of those we got 2 real rational numbers. One we got 1 real rational number. Another kind we got 2 irrational, and then the other kind we had 2 complex roots. Okay, so those are the 4 possibilities, and it's all based on what number you get in the discriminant, or the part that's under the square root. Okay, so let's look. Here's kind of an overview of the whole thing, and then we'll do a few examples and we'll be done. The first part here says, if you have, basically what this says is, if the discriminant is positive, that's what the greater than 0 means. If this is a positive number and it's a perfect square, then you're going to get 2 real rational roots. So remember how this works is, let's say you have something like this. Let's say you have 2 plus or minus the square root of something over 2. Well, if it's a perfect square, if this is a perfect square, like let's say 64, then what happens? The square root part goes away, and you have like 2 plus 8 over 2. And you could do that's 10 over 2 or negative 6 over 2. You have 2 real numbers, okay, 2 rational numbers. What happens though if, again, if it's positive, but it's not a perfect square, okay, it's not a perfect square. Well, what's going to happen there is, let's say you've got 2 plus or minus, you know, the square root of 17 over 2. Well, then this part does not simplify, and you're going to be left with an irrational number, okay, because it won't simplify. The square root won't go away. It will stay there, so it's going to be irrational. And there's 2 of them, because plus or minus. Whenever you see that plus or minus, that means there's 2 parts to it. There's 2 roots, one positive and one negative there. Then the third possibility here is if the discriminant is equal to 0. And so let's say you had 2 plus or minus the square root of 0 over 2. Well, what happens there? Basically, when this becomes 0, it takes away the plus or minus, because it's 2 plus 0, which is 2, or 2 minus 0, which is also 2. So this would just simplify to 2 over 2, or just 1. And so whenever we have 0 for our discriminant, it takes away the 2 root part. That basically means both roots are the same thing. And of course you can see the graph would look something like this here, where you have the graph and it just touches in one spot. And then the last one, if it's less than 0, basically that means if it's negative. And so anytime you've got a negative square root, it's always going to be an imaginary number, which means 2 complex roots. So let's say you had something like, you know, 2 plus or minus the square root of negative 16 over 2. Well, this would just simplify to 2 plus or minus 4i over 2. And then you could simplify that. 2 divided by 2 is 1, and 4 divided by 2 is 2, so you can say 1 plus or minus 2i. But you notice it's complex because there's an I in there, but there are 2 roots because there's still the plus or minus. So The whole thing is, whenever you stuff a plus or minus in there, there are two roots. When you have 0 for your discriminant, the plus or minus goes away and you just have one root. But anyway, so that's kind of a quick overview. Let's do a few examples. The discriminant. So we're just doing the discriminant here. We're not working out the whole thing. So remember, that's just the b squared minus 4ac part. So let's just do that. What's b? b is 3. 3 squared is 9 minus 4 times 1 times 5. So this is going to be 9 minus 20, which equals negative 11. So the discriminant is negative 11. What does that mean about the roots? It's negative, so that means we're going to have what? 2 complex roots. That means you're going to get 2 roots that have an I in them. Okay, so 2 complex because of the negative. Okay? Next. Again, remember, b squared minus 4ac. So b is negative 11. Negative 11 squared is 121. Minus 4 times a is again 1. C is 10. So this is going to be 121 minus 40. Okay, and 121 minus 40 will be 81. The discriminant is 81. That's positive. Is it a perfect square? Yes, 9 times 9 is 81, so that is a perfect square, and it's positive, so that means we're going to have 2 real and rational roots. Okay, 2 real rational roots. Because if you took the square root of 81, the square root would go away and it would be rational, not irrational. Alright, how about this one? Again, remember b squared minus 4ac. So b is 8. That's going to be 8 times 8 is 64. Minus 4 times 1 times 16. And so again, 4 times 16 is 64. Oh, 64 minus 64 is, whoops, my mind was jumping ahead there. 64 minus 64 is 0. So if the discriminant is 0, what do we get? We get 1 real rational root. Because remember, whenever we get 0, that takes away the square root part completely and takes away the plus or minus, so we only get 1 root. Alright, last one here. Again, remember, b squared minus 4ac. b squared, that's 64. Minus 4 times, this time a is negative 5, and c is negative 1. And so we've got 64. Well, now let's be careful here. What do we got? Well, technically, this works like negative 4 times negative 5 times negative 1. So this is really like a negative times a negative is a positive 20. And then 20 times a negative 1 is minus 20. So this would come out to be 44. So if the discriminant is 44, it's positive, so it's not complex or not imaginary. Is it a perfect square? It's not a perfect square. Okay, so this would be where we would have to say that there are 2 roots, but they're irrational. 2 irrational roots. So remember, if it's perfect square, they're rational. If it's imperfect square, they're irrational. If it's 0, there's 1 rational root. And if it's negative, that's where you get the imaginary numbers, so they're complex, 2 complex roots. Okay, well that's going to do it for this section here for the quadratic formula and the discriminant. The Falcon and the Snowman. That was a movie from like way back. Or even Kowalski and LaRue. Kowalski and LaRue, that's another famous one. Anyway, that's going to do it for this section. Mr. Anderson signing off. Well, see you next time. Bye.